we'll go ahead and start. So welcome everyone. My name is Tyler, and I am a scientist at UC Berkeley, which is a university in Berkeley, in the East Bay area. I heard a lot of you tell me this morning that you are either from San Francisco or the South Bay area. So I'm so encouraged to see all of you. And I am a certain kind of a scientist called an engineer. Engineers, we use science and math to solve problems. And we're going to be getting a chance to solve a really important problem today, learning about chemistry. So Jade, do you want to introduce yourself, say hi, and then you can start our screen share as well.
Awesome. Thanks, Tyler. Hey, everyone. Can you give me a thumbs up if you can hear me okay? Good. Glad to hear it. So my name is Jade, and I am also a scientist. I'm a scientist at UC Berkeley, and I'm a particular kind of scientist called a chemist. Has anyone heard of a chemist before, or chemistry? Maybe give me a thumbs up if you've heard of chemistry, or a thumbs down if you haven't. Got some thumbs up. Cool. Yeah, so I study chemistry at Berkeley, and in particular, I make beautiful, colorful crystals, like every color of the rainbow. That's my job every day, is to go into lab and make crystals, and then I shoot x-rays at them to try to see what they are. So maybe if you've had an x-ray of your arm, if you've broken your arm or something, I take x-rays of tiny crystals instead of bones. So really fun and cool. And I'm super excited to talk to you guys today about chemistry, and to hopefully we can solve a puzzle together, because I think puzzles are the best part of science. Tyler, do you want me to take over the screen share now?
That would be great. I believe that I've given you options to do that here at the bottom. Yeah, go ahead and try that.
I need you to stop sharing so that I can start.
Sorry about that.
No worries.
All right, everyone. Sorry for the slight technical issue. We've got lots of more people joining us today. So I'm so glad that we've got even more people joining our lesson today. Excellent. Wow, for those of you that are just joining us, my name's Tyler, and this is Jade, and we're learning about chemistry today.
Yes, awesome. So this lesson is called Chemistry Liquids, because we're going to solve a chemistry mystery with your guys' help. So this lesson was created by myself and a bunch of my cool scientist friends. So they're not here today, but you're going to see some of them in the videos that we'll be watching. So I thought I would introduce them to you. So you're going to hear today from Ethan over here on the side of the screen. And a fun fact about Ethan is he rides a motorcycle. You're also going to watch a video featuring my friend Amanda here in the bottom. And a fun fact about Amanda is that she likes to ride bicycles. Does anyone here like to ride bicycles? Maybe raise your hand if you like to ride bicycles. I love bicycles.
I see Ria, Vedant, Ali, Arya, Hugo, Divya. Oh, so many people love riding bicycles.
Bicycles are awesome. We're also going to hear from my friend Eric in one of the videos. And Eric grew up in the Rocky Mountains of Colorado, which is super cool. And he loves to ski. So in this picture, you see him skiing. He's wearing a hat, a big winter coat, pretty cool. I'm Jade, so a fun fact about me is I can do a headstand. I'm not gonna do that right now, but just so you know. And then we're also gonna hear from my friend Isaac in these videos today. And Isaac loves nature, which I heard a lot of you guys saying. I think Vedant said that earlier, that he likes nature. Nature is fascinating, so Isaac agrees with you. So these are just a few scientists that are my friends at Berkeley, and these are the scientists who helped me make this lesson today. Okay, so to get started, I think we should talk about what is chemistry. Like, some of you have heard of that word before, but have any of you guys ever done chemistry? Has anyone ever done a chemistry experiment? I see Shrey is shaking his head no. Well, I think that a lot of you guys actually have done a chemistry experiment before. So I have a question. Has anyone in this Zoom room ever baked a cake? Raise your hand or give me a thumbs up if you've baked a cake before. Or maybe you've watched someone bake a cake or you've helped. So baking a cake is chemistry. So let's talk about that. So if I want to bake a cake, I need to put some ingredients into this bowl. What kind of ingredients go into a cake? Does anybody want to raise their hand and tell me one ingredient that goes into a cake?
Oh, I see some
I'm going to
very,
call.
very quiet hands. Can we call on Nandini? Nandini,
Yeah.
go ahead and unmute yourself and tell us what goes into a cake.
Well, eggs go into a cake.
Totally. Awesome. Let's hear some more answers. You're totally right. Tyler, do you want to moderate? Will you call
Yeah,
in students for me?
absolutely. I see so many quiet hands. Aria, why don't you tell us what else goes into a cake?
Flour.
Flour.
Flour, great.
Oh, sure, they said flour.
Excellent. And Ria, do you want to tell us something else?
Yeah, sugar also goes into a cake, and milk also goes into a cake.
Sugar and milk. Excellent.
All right. Let's take
I don't
one
know
more.
anything.
All right. And Abby, thanks for your quiet hand.
Baking powder.
Nice. Very good. All right. So here are some of the ingredients that you guys mentioned, and some maybe that you hadn't thought of. So we have the sugar, we have the flour, we have the eggs. Sometimes we put chocolate in. We totally put baking powder into cakes. I should have put that on this slide. Sometimes we put in sprinkles. So these things all go into a cake, right? So I have all my ingredients and then I mix them together in this bowl, right? Is this a cake? What do you guys think? Shake your head yes or no. Is this bowl a cake? No. What do I have to do? Can anyone raise their hand and tell me what I need to do to turn this into a cake?
Oh, excellent. Let's call on Finley. Finley, what do you have to do?
You have to cook it.
Totally.
Yeah.
That's awesome.
I'm
Yeah.
seeing some great responses in the chat as well, saying to
Cool.
cook it or bake it or heat it up. These are all
Yeah.
great ways to make a cake.
You guys are totally right. I have to take this bowl of ingredients and bake it to turn it into a cake. So now I have a really important last question for you guys. Now that I have this cake here in the middle of the screen, could I possibly take the eggs back out? What do you think? Could I take the eggs back out of that cake? Seeing some heads shaking no.
Students, I want everyone to give us a either thumbs up or a thumbs down if you think you can get the eggs back out of the cake.
Yeah.
All right.
And a lot of emphatic thumbs down. Okay, so that makes sense. We can't take the eggs back out, but how about the flour? Could I take the flour back out? No, the sugar? No, you guys are totally right. And so this is because I did a chemical reaction. I took the sugar and the flour and the eggs and the chocolate and I mixed them all together and I baked them and I turned them into something totally new called a cake. Now that it's a cake, I can't take the eggs back out, right? Because I changed the eggs into a cake. So this is what chemistry is. Chemistry is taking ingredients or chemicals and turning them into something totally new. So we do chemistry in our kitchens every day. Every time you cook something in your kitchen, you're actually doing chemistry. So if you've ever cooked something before, even just putting bread in the toaster, you're a chemist. So raise your hand if you think you're a chemist now that I've told you about this. If you've made toast, you're a chemist. If you've boiled water, you're a chemist. Yeah, totally.
I see
All
so
right.
many hands up. Thank you for telling us that you're chemists. For those of you that have just joining us, we are so excited you are here. If you're able to, we'd love to see your faces so that we can get some of your responses and call on you if you have questions today. I also want to let you know that you can type anything into the chat if you have any other questions about that. And finally, just make sure that you leave yourself on mute unless we call on you so that we can make sure our lesson runs smoothly. All right, so let's keep going.
Cool. So we just talked about how cooking is chemistry, and that's totally true. But when I go to a lab, sometimes I do chemistry with things that we don't eat. So I do chemistry with things called chemicals. So that's a word that basically means anything in the world. So chemicals can be solids, liquids, or gases. So let's talk a little bit about each of those three things. Tyler, do you want to talk about solids, liquids, and gases?
Yes, so solids, liquids, and gases are what we call states of matter. Now, solids are things that are hard and they keep their shape. I would venture a guess that everyone has something that is solid near them. Can I get everyone to point to something that is solid? So I'm pointing to a container, and this is something that is solid. I see some people holding up like a hairbrush or a pen. Those are great examples of solids. Jade's got a spoon and a cup. Oh, I see a pumpkin from Nandini. That's a great example of a solid. And so this is one example of, or these are many, many examples of solids. Another type of chemical can be found as a liquid. And a liquid is something that can be kind of wet or that it flows. So the reason that I was holding up this bottle of hand sanitizer is I want to let you know that there is liquid inside my solid. And so the solid can hold the liquid together. And so lots of chemicals are in the form of liquids. Can somebody raise their hand and give me an example of something that is a liquid? Ria, thank you for your quiet hand.
Orange juice can be a liquid.
Orange juice is a liquid. How about one or two more liquids? Can you tell us? Alice, what's a liquid?
Water. Applesauce. Maybe
That's great, Alice. I heard somebody else say water. I will take one more response from Srisha. Srisha, thanks for your question.
Lemonade.
Lemonade, excellent examples of liquid. And finally, our last state of matter is called a gas. And gases are, we, for the most part, cannot see them at all. And they're like, for example, the air that we breathe. So can I get everyone to take their hands and gather all the gas around them? Move your hands all around. See if you can gather some of that gas. Yes, great job. I see everyone grabbing as much of the gas around you as you can. So those are our three states of matter: solids, liquids, and gases. And we're going to be getting a chance to do some chemistry using some of our states of matter today.
Yeah, totally. Thanks, Tyler. So today's lesson is about liquids in particular. And we're going to talk about 4 different liquid chemicals today. So maybe you've heard of some of these before. So one liquid that we're going to be talking about is called hydrogen peroxide. And it's over here on the side of the screen in this brown bottle. Can anyone raise their hand if they have interacted with hydrogen peroxide before? Have you seen this maybe in a store or at your house, maybe used it?
I see Emma with a raised hand on this. Good. Same with Riley. Aria, you're giving me a thumbs down like maybe you haven't with before. Nice, nice.
So it seems like some of us have seen hydrogen peroxide before. Maybe we could get one person to volunteer where they have seen hydrogen peroxide in their life.
Enzo, you've had a quiet hand for a long time. Can you tell us?
Well, I've seen hydrogen peroxide in my garage because we use it in my fountain out in the front of my house to get all the algae out of it.
Cool. That's an awesome connection. Thanks, Enzo. So Enzo said that they use hydrogen peroxide to keep algae out of their water fountain, which is awesome. That's a great use of hydrogen peroxide. When I was a little girl, whenever I got a scrape, my grandma would put hydrogen peroxide on my scrapes to clean it out, and it kind of stung and like had bubbles. Maybe some of you have had that experience before as well. So another liquid that we're going to be talking about today is called baby oil. Has anyone heard of this one? It's in this pink bottle in the middle of the screen. We've got some people shaking their heads yes, some people no. Yeah, so it's a liquid as well. Another liquid that we're going to talk about today is called vinegar. Has anyone heard of vinegar before? I see Enzo is raising his hand and nodding yes. Okay, Milo and Hugo are nodding. where have you used vinegar before in your life? Can anyone raise their hand and volunteer?
Oh, a quiet hand is from Ethan. Ethan, can you tell us? Where have you used vinegar before?
A rocket ship. One rocket ship, you need a baking soda and vinegar.
Awesome.
And a volcano needs vinegar.
Yeah, awesome. Thanks, Ethan. So Ethan's used vinegar in science before to make rockets and volcanoes, and that's kind of what we'll be doing today. You can also use, yeah, Tyler.
Oh, I see also Abby and Logan with a quiet hand. Do you want to tell us another example of where you've used vinegar?
I've used it to clean my guinea pig cage.
Ooh. Awesome. All right, so cleaning, that's another definite use of vinegar. Let's maybe hear one more. Maybe one more use of vinegar.
All right. Oh, Vedant, thank you for a quiet hand.
I use it in fizzy tablet experiments and volcano.
Awesome. Volcanoes again, cool. I like to eat vinegar in my salad dressings. Has anyone ever eaten vinegar before? It's a food, you can totally eat it. Yeah. So there's a lot of different ways that we've all experienced vinegar. There's one more liquid that we're going to talk about today that maybe you haven't heard of, and that's okay. It's called sodium hydroxide. This is a liquid that is from my chemistry lab. So this isn't one that's really easy to get at your home, but we're going to talk about it today because we're going to do a cool experiment with it. So these are the 4 liquids that we are going to be looking at today. So here we go. I'm going to play this video for you guys, and it's going to sort of describe the problem that we are going to solve today. So when you're watching this video, I want you to watch carefully and listen, and then we will talk about the puzzle that we're going to solve today. All right, so here we go. I'm going to go ahead and start the video. Shoot! Oh no! What am I going to do?
You ready to do some demos?
I thought I was ready, but I think I made a mistake, Isaac. We need the hydrogen peroxide for the first demonstration. And so I poured all the liquids into these nice bottles because I thought that they looked really nice. But I forgot to label which bottle is which. And so I thought maybe I could look at the liquids and figure it out, but they're all colorless. Yeah. They're all colorless liquids. So I'm not really sure what to do. We have to dump it all out and start over.
Well, no, I don't think so. I think we might be able to figure this one out.
Oh yeah?
Yeah. Well, we know what the 4 liquids are, right?
Yeah, we have vinegar, hydrogen peroxide, sodium hydroxide, and baking oil.
Okay. And each of those is a different type of liquid.
Yeah.
Has different properties, right?
Different properties? What do you mean?
Yeah, like each of these liquids behaves differently.
Okay.
So maybe we could add things to them, and they would behave differently if we added the liquids.
You know, that's a good idea, Isaac. I think that could work. Do you have any ideas for maybe the vinegar? What would the vinegar do?
Well, the vinegar might react with baking soda.
Oh, I've seen that before in my kitchen, like the volcano reaction. Yeah, and I know that the other ones would react, so that's a great idea. What else could we do? Baby oil is one of them.
Yeah, well, I think that doesn't mix with food coloring.
Oh, you're totally right. So for the other ones will. So we could add some food coloring. That's a great idea. But there's still 2. There's still the sodium hydroxide and hydrogen peroxide. What about those 2? Sodium hydroxide.
We might have an indicator that changes colors when it gets mixed.
That's so cool. Okay,
Yeah.
so that would work. So then we can figure out our vinegar, our baby oil, and our sodium hydroxide. And the only one left is the hydrogen peroxide. So that's a great idea. Wow. So we can use science experiments to figure this out. Cool.
Great.
All right.
Well, everyone, I got a couple of comments saying that it may have been a little bit difficult for you to hear the video. So I want to let you know that this was our intro video that talked about how we can determine which liquid is which liquid. we've mixed them all up and we don't know which one's which. And because they're all clear, we don't know which liquid we can use for our big reaction at the end. So we've set up a number of science experiments using chemistry in that video to determine which liquid is which liquid.
Awesome. So if you guys can see this picture on the screen are the 4 different liquids. Can anyone tell any difference between those 4 different cups of liquid? Can anyone see any differences?
Why don't you give me a thumbs up if you can tell a difference, and a thumbs down if you don't see any differences at all between all 4 of those containers.
Ooh, yeah.
Luca's giving me a thumbs down, but I see some thumbs up as well. Ethan, thumbs down. Yeah. Okay, for somebody who's given me a thumbs up, what's the difference that you notice between those containers right now? How about Ria?
One of the differences I see is like in the second container, there are like a lot of like little water drops on the side of the cup, and there aren't water drops on any other cups, like on the sides.
That is a good observation. Yeah.
All right. But for the rest of you, it looked like most of you were giving me a thumbs down, and they all appear to me like they are clear cups that look pretty similar, right? So what we're going to do now is we're going to look at some of the experiments to help us determine which one is which.
So we're going to be using this table to keep track of our results. We will keep track of them on the screen with your guys' help, but you're going to see this come up a lot. So in order to start telling the difference between these liquids, we started out by just labeling each of those 4 cups, A, B, C, and D, just so we have some way to tell them apart. So then we're going to do a series of experiments where we see which liquid has which property. So in the first experiment, we're going to add baking soda to liquids A, B, C, and D, and we're going to look for the one that forms bubbles, because we know that one of our liquids is vinegar, and as many of you pointed out, we know that vinegar can react with baking soda in the volcano reaction. So we're going to look for the liquid that has bubbles to know that that is vinegar, the one that we're looking for. So what this will look like after we do the experiment is maybe we'll say A didn't have bubbles, B didn't have bubbles, but C did, and so C must be vinegar. So this is just a practice. We'll go through this after each experiment. All right. So we're going to use, yeah, Tyler, you want to share?
Oh, so what I was saying, students, is as you watch the video, even if it doesn't come through perfectly or you can't hear what it is that they're saying, remember that we're looking for which one of these creates bubbles, okay? So use your eyes, use your ears, all of our senses to try to figure out which one that is.
Okay, so in this first experiment, like we were just mentioning, you're going to see one of my scientist friends add baking soda to each different liquid, and we're going to watch for the one that bubbles. So even if you can't hear it, we can still watch with our eyes, okay? So shall we go, Tyler? Does that sound good? Okay, here we go. This is experiment number 1.
Hi guys, today we're going to be doing experiment number 1, and we're going to be doing the reaction station. The reaction station is going to occur when we mix one of these mystery liquids with our baking soda and produce bubbles. So I've labeled each of these vials with A, B, C, and D, and we'll pour in our mystery liquids and test it by pouring in some baking soda. So let's start our pouring. Pull the D. Pass it on this D. So make sure you guys check out your tables. You'll have D, C, B, and A on your tables, and we're going to pour our baking soda in and see if we see any bubbles.
All right, so this is where we're watching for bubbles.
So we'll test D first.
Ethan is adding baking soda to liquid D.
No bubbles. So mark that on your table, guys. No bubbles for D.
All right.
No bubbles.
Hold that in your head. D did not have any bubbles.
And for C, no reaction, no bubbles, no good. So mark that on your table. And let's try B. Swirl it around a little bit and see if we can get anything. Looks like no bubbles. So last but not least, let's try A. Whoa, we're getting some awesome bubble action. Wow. So we did it. We found our mystery liquid. A is the one that reacts with the baking soda. And make sure you guys mark that on your table so we can use it in the next experiments.
Okay, so let's talk about what we saw in that video. Tyler, do you want to moderate this part?
Absolutely. So students, we did the same thing to all 4 of our liquids, but which container is the one that created bubbles? Can someone raise their hand and tell me? How about Luca? Luca.
A created the bubbles.
A created the bubbles. Excellent. So we learned that A must be vinegar, right? Because vinegar is our clear liquid that can interact with baking soda to create a bubble reaction. So in science, we can make observations and we can determine that this liquid right here, A, is probably our vinegar. So if you have a science notebook or journal that you'd like to copy down this table in, or you can just follow along on our screen. This works great. But notice here that we've put the circle in the A column because it did create the bubbles. And in B, C, and D, we put X's because no bubbles were created. So we've got 2 more experiments to determine what a couple of our other liquids might be. So go ahead and put your observation glasses on, and we're going to take a look at the next video here.
Okay, everyone. So in this experiment, we are going to add food coloring to each of the liquids, and one of the liquids does not mix with food coloring, and that liquid is baby oil. So in this experiment, I want you to watch my friend Eric add food coloring to all of the liquids and look carefully for the one that doesn't mix with the food coloring. So here we go. Experiment number 2.
Hey, my name is Eric, and welcome to experiment number 2 in our unknown liquid experiments. So at this station, we're going to mix some liquids, and one of these 4 liquids will not mix with our food coloring. So I'm going to go ahead and I'm going to pour each of our liquids into our test tubes, and then we're going to add our colorful food colorings to them and see which one of these will mix. All right, so now we have all of our blood liquids poured into our test tubes. So let's go ahead and start adding color. So I'm just gonna pick randomly here, and I guess we'll start with our unknown liquid D. And I guess I'm gonna try to put some red food coloring in this one. So remember, we're looking to see if the food coloring mixes. So just a couple drops. Oh, looks like it's starting to mix in there. Let's give it a shake. Yeah, really red. Definitely looks like this is mixing pretty well with our liquid. So it's probably not the one we're looking for. All right, next, let's try C. And we'll go with green this time. Again, just a drop or two. Oh man, looks sort of similar to the last one. It's kind of mixing in there really quickly. Give it another few shakes. And yep, got some nice green. So far we have our Christmas colors. All right, what should we do next? A or B? We'll try A. All right, we'll try A. And I'm gonna go with some yellow food coloring. And do a couple drops. Ooh. A little reddish, but let's mix it up and see how that turns out. Whoa, all right, orangish. And definitely mixed in, right? So I guess we can cross out A as well. That looks like A, C, and D all mixed. So let's try B. I'm gonna go with blue this time. Give it a drop or two. Whoa. See that? Not mixing at all. Just falling as like a big bubble. Should we try one more? Maybe we just don't have enough food coloring. That's pretty cool. Just drops down there. Maybe if we mix it hard enough, shake it, we can get it in there. Doesn't really look like it, huh? So what does that tell us? We have unknown liquid B, and it looks like of all of our 4 liquids, B is the only one that won't mix with our food coloring. So that's probably the one we're looking for, right?
All right, everybody.
If you have your sheet, we can go down ahead and mark B.
So really sorry about any glitches that you may have seen on the video, but for somebody that did see it, which one of those liquids, which letter was the one that didn't mix with the food coloring? Yeah, Mia, which one did you see?
B.
Yeah, excellent, Mia. It was B. And so what we had learned before is that the liquid that wasn't going to mix with the food coloring is the one that is oil. And so what we can learn about this is that we already learned from the last experiment that A is vinegar. And on this one, that we've learned that B is going to be our baby oil. In some other science experiments, we've seen that oil and water don't mix together. If you have oil and water in your kitchen, this is something that you can learn about or think about and experiment on. But this is what we've learned from our experiment, that B is baby oil.
Awesome. Thanks, Tyler. Okay, so now we're going to head into the last experiment before the final demonstration. So in this experiment, you're going to see my friend Amanda adding something called an indicator to all of the liquids. So this is a really cool chemistry experiment that we actually use in the real lab every day. So one of the liquids, the sodium hydroxide, is going to turn pink when it gets mixed with the indicator. And none of the other ones will turn pink. It's really cool because the indicator itself is totally colorless. So in this experiment, we're going to look for the colorless liquid that turns pink when the colorless indicator is added. And even if you can't hear Amanda, you should be able to see very clearly when the pink color appears. All right, so let's watch together.
Hi everybody, my name is Amanda and I am going to show you experiment number 3, looking at the indicator solution. So what we're hoping to see here is that one of these solutions responds to our indicator solution and is going to turn pink. So first I'm going to fill up the tubes with each of our mystery liquids, starting with A. Alright, so now we've got our solutions, and I'm going to add just a drop of this indicator solution to each one. So this is sensitive enough that even one drop should let us know which of these is going to respond. So let's start with A. And let's see what happens when we add a drop.
So the indicator is in this cup over here that Amanda has the pipette in.
So no color change on that one. Let's add one more just to be sure. All right, so that one seems like it's staying pretty transparent. Remember that we want to look for the one that's going to turn pink when we add our indicator. So now let's try B. Let's add 1 or 2 drops. And not seeing a color change. Let's shake it up a little bit. Nope, still looks pretty clear. So let's move on and try C. Oh, that is definitely turning pink. Can you all see that?
Whoa.
Let's shake it up a little bit. So as soon as we added that one drop, look at that.
So pretty.
That is a lovely pink color.
Pink is my favorite color.
Back here. Now, just to be sure, because we're good scientists and we're thorough experimenters, let's see what happens when we try adding a drop of the indicator to B. Couple drops. So this one does not seem to be turning pink. Shake it up a little bit. Nope, still looks pretty transparent. So let's go back through and look at each of these. So we've got A, B, C, and D, and you can see that compared to A, B, and D, C is clearly very pink. The rest are very transparent. So you can go ahead and mark on your sheets that C is the sample that turned pink when you added the indicator solution.
I think we should go back and watch the color turning pink one more time because that part is so cool. Let's watch Amanda add that one drop of pink one more time. That was so fun. All right.
And not seeing a color change. Let's shake it up a little bit. Move on and try C.
All right, here we go. One more time. It was so cool. Whoa.
That is definitely turning pink. Can you all see that? Let's shake it up a little bit. So as soon as we added that one drop, look at that.
Super
that is a
cool.
lovely pink color.
Ah, thanks for humoring me. I just love that experiment so much. Okay, so does anybody remember which one of those liquids was different than all the others? I think I saw some answers in the chat, but maybe you want someone to raise their hand and volunteer as well?
Yeah, Aria, which one was it?
So what do I say?
Aria says C. And that's what the chat looks
Totally.
like as well.
Yeah, you guys are on it. So of all of those liquids, only one of them changed color, and that was C. So C must be our sodium hydroxide. All right, so let's play a little game here. I want to draw lines to connect the letter labels to the liquid that they are. So I'm gonna click the screen and some lines will show up on the screen. And I want you guys to tell me if I've drawn the lines correctly or not. And you can do that with a thumbs up if you agree with how I've drawn the lines, or a thumbs down if you don't agree. Okay, so this is what I think we saw. I think that A was vinegar because it bubbled. I think that B is baby oil. I think that C was the sodium hydroxide. And I think that D is the hydrogen peroxide. So what do you guys think? Do you agree with my analysis of these experiments, or do you disagree?
I see lots of people giving me thumbs up. I also thank you for helping to moderate the chat, Emma. I saw lots of people putting C earlier, but we've already gone over that part. So I see some Ethan thumbs up, Aria thumbs up, Alice, nice, Clara, awesome, Arwen. Yeah, so it looks like you guys think this is right.
Okay, cool. So if this is right, then we've solved the mystery. We've decided that A is vinegar because it had bubbles with baking soda. We've decided that B was baby oil because it didn't mix with the food coloring. We saw that C was sodium hydroxide because it turned that beautiful pink color when it was mixed with the indicator. And so the only one left has to be D, hydrogen peroxide, right? So this is cool because the hydrogen peroxide is the one that I was looking for our last demonstration. So has anyone ever heard of the elephant's toothpaste demonstration? Sometimes called the exploding foam tower. Give me a thumbs up if you've heard of the elephant's toothpaste demonstration.
I see
So
some
really,
thumbs up, some thumbs down. Yeah. Rhea, you were especially excited about this one.
Yeah, we're gonna watch this demonstration together. It's a reaction that happens between hydrogen peroxide and a catalyst called potassium iodide. And to make this demonstration more exciting, I'm gonna add dish soap, so there's lots of bubbles, and rainbow colors. So let's watch together.
And students, if you don't see this very well, there will be a recording of it afterwards.
Exploding foam tower, or elephant's toothpaste demonstration. So if you were following along, you need hydrogen peroxide to do this demonstration. So which of the liquids, A, B, C, or D, is hydrogen peroxide based on the experiments that you guys did earlier? If you were following along, that's correct. It's D. D is the hydrogen peroxide that we're looking for. So now we're going to do exploding foam tower demonstration. I'm going to pour 100 milliliters hydrogen peroxide into this tall piece of glassware called a graduated cylinder.
So she just poured it into the graduated cylinder. And now is adding dish soap.
And I'm just going to swirl it around to mix it into the hydrogen peroxide.
We want to make sure that hydrogen peroxide is really mixed together with the dish soap.
And now I'm just adding rainbow colors because I love rainbows. I don't know about you guys, but I think that everything is more exciting when it's colorful.
I loved seeing everyone type their favorite colors into the chat earlier. That was great.
Ready to do final step demonstration. I'm going to add 1 scoop of this catalyst, which will start the reaction. And we'll get to see our awesome exploding foam tower. All right, you guys, I'm about to add the catalyst. We're going to do a countdown. Ready? 3, 2,
1, go.
Here we go. Woo! Awesome. Yeah. See all the steam coming off the top? It's from the heat of the reaction. It's really warm over here. We have beautiful rainbow colors, foam dripping around the side. Come closer. You can check it out over here. Pretty rainbow, looks kind of like toothpaste, still coming out the top. Awesome. All right, everyone. Nice work. Thanks for watching. Okay, everyone. So that's my favorite. That's my favorite chemical reaction, and it was so fun to share it with you guys today. All right, I'm going to stop the screen share now.
Can I get a quick show of hands? Who thought that that was a cool chemical reaction that we got to see today? Yeah, I saw Sheree.
Whoa, amazing.
Clara. Yeah, that was pretty cool. And so this is just one of the great things that we get to do as chemists, and thinking about reactions and the ways that different chemicals and different states of matter, specifically liquids that we're looking at today, can react with other things like the solid that Jade put inside. So we have just a couple of more minutes left on our session today, but I wanted to open it up to see if anyone had questions for Jade and myself, either about the mystery liquids that we learned about today, or about science, or about just anything else. So if anyone has a question, you can raise your hand and we will call on you to see what your question is. Aria, thanks for a quiet hand. How about you?
Can I touch it or will my hand burn?
Oh, I heard your hand burned. That's no good.
She's asking, can she touch it or will her hands burn if she touches that?
Yeah,
You can touch it. Yes, it's
a
safe
good
to touch
question.
it. It's a little bit warm, but not too hot if you were to do
Yeah.
the elephant toothpaste experiment at home. Anyone else have a question today? All right, how about Enzo?
Well, like, what ingredients do you need to do that experiment?
Jay, do you want to review what you put into the test tube?
Yes, to do that experiment at home, you need hydrogen peroxide, which you can buy at a drugstore. You need dish soap. You can add food coloring. And then the last thing that I added is called a catalyst. So unfortunately, you can't buy that in a store, but you can buy a different catalyst that totally works called yeast, Y-E-A-S-T, yeast. Someone heard of yeast before? You might use it in your kitchen to bake bread. Yeah, I'm seeing some hands up. People know what yeast is. Awesome. So if you warm up the yeast in some sugar and water to activate it.
Yeast was used in elephant toothpaste.
Yes, so the yeast can be used to start the elephant's toothpaste reaction. So you can do this reaction at home with hydrogen peroxide, dish soap, and yeast. Really great question, Enzo. Thank you for asking that.
One more thing about doing elephant toothpaste. Students, if you're thinking about doing elephant toothpaste at home, make sure that you get your permission from your parent or guardian. And just because it can be a little bit dangerous to do chemistry when you're not supervised, make sure that they're there with you to make sure that everything is going safe and that you're taking good precautions. All right, we've got time for a couple more questions. How about Abby? You've got a quiet hand up.
Do you recommend any good science kits?
Abby, there are so many great science kits and opportunities, a lot of which you can buy from different companies and stuff. The science kits that I would recommend, make sure that you get stuff that is hands-on. Some of the kits have to do with building, so I can't necessarily recommend any specific ones, but make sure that you get things that allow you to build or combine some materials together and that you can try experimenting with. That's a great question. Ria, thanks for your quiet hand.
My question is that if you make the elephant toothpaste, should you make it inside or outside?
Really good question. I've done it inside and outside. I think it's probably better to do it outside, or you can even do it in your kitchen sink, right? Because then you can just wash it down the sink when you're done if it does make a mess. But very good question, inside or outside. But if you're inside, you're gonna wanna be careful about where you pick.
Ria, if you do it outside, just make sure that you have a tarp underneath so that it doesn't get into the grass or and maybe hurt any animals or anything that are around you.
Okay.
All right, we've got
Thank
time for
you.
2 more questions. How about Connor?
The question that I wanted to ask is, what else do you guys study as a scientist?
Awesome question. What do we study as scientists? So I mentioned this a little bit earlier, but I study crystals. So I study different ways that solids can form crystals. And I am interested in particular in different colors of crystals and why there are different colors, and also what about them causes them to be different colors and shapes. So I try to take x-rays of crystals to look inside of them and see what is it about the inside of that crystal that makes it different shapes and different colors that we can see with our eyes. That's a really good question. What about you, Tyler?
Great question, Connor. And the kind of science that I study has to do with sound. So I get to learn about sound waves and how they interact with different substances or materials. And it's very exciting to think about how sound works and how it travels. But in science, there are so many different things that you can study. I have friends that study everything from how to make bridges safe to studying a specific animal. Or I have some friends that study some really small things like microbes. There are lots of questions that scientists ask about the world, and science is one of the most important and great ways that we can study to solve some of those questions that we really have.
Yeah.
Great
I want to
question,
add one
Connor.
more thing really quick to that. So do you remember some of those people we were seeing in the videos? They all study different types of science too. So my friend Ethan from the first experiment, he studies solar panels. He tries to make the best solar panels possible. So that's super important. My friend Amanda from the last video, she studies cells and particularly how to fight cancer. So that's really important too. And let's see, Eric in the middle video, he's looking for new ways to break down plastics. Have you ever seen like plastic litter? It makes us kind of sad. He's looking for ways to break apart plastics so that they don't harm the environment anymore. There's lots of like really cool, important problems that scientists get to think about and try to help. Great question. Thanks again, Connor.
All right, I'm going to end our recording here. And if you need to head out to another session, go for it. But we will stay on for a couple more minutes to answer some more questions if you've got them. Thanks.